to see how we can use kinematics to solve free fall questions. So let's say we have a ball at top of the building with some height. We want to basically calculate what is the time that it takes for this ball to reach the ground. And what is the final velocity of the ball? Okay, the first case would be when the initial velocity is equal to 0 meter per second. It means that the ball was released from some height. We want to solve for time. And we know that the h is given. For example, 10 meter is the height of this building. The equation that I'm going to use is delta y is equal to 1/2 at squared plus v naught t. The first thing that I have to consider is that what is the acceleration? As long as I'm talking about kinematics, in y direction, I know that in y direction, the only force acting on this ball is the force of gravity. So the acceleration would be equal to gravity, and it's equal to minus 9.8. When you're using gravity, don't forget this negative. You will always insert the gravity with this minus in all of your equations. So now I want to solve for t. I have delta y, which is the height of the building. It goes from here, which is my y naught, to here, which is my final y. So y minus y naught is equal to 1/2. What is y and what is y naught? This is 0, and this was equal to h. So y minus y naught is negative h, equal to 1/2. What is acceleration? It's negative 9.8. What is the initial velocity? It was 0. Now I can solve for time. Minus h is equal to 1/2 minus 9.8 t squared. These two minus will cancel out. And I will rearrange the equation for t. T squared is equal to 2h divided by 9.8. Then the time is equal to 2h divided by 9.8 under the square root. And my h was equal to 10 meters, so 20 divided by 9.8 seconds. This was the first example with initial velocity equal to 0, which we are going to see an example of this case.
Can we solve this equation considering both difference height and acceleration positive?
Well, it was a really good question. You actually can do that because when we solved this problem, we were considering that the positive y was upward. So now I'm going to rotate the coordinate in a way that my positive y is downward. So in that case, the height would be positive and the acceleration, which is g, and it's always to the ground, is also positive. So I would have h equal to 1/2 9.8 t squared. And because the velocity was 0, it would not affect this initial velocity, and it still is equal to 0. But if I had that velocity, then I have to consider that initial velocity direction also.